This is the solution video for Unit 4 review problem number 12. Let f be the function with derivative given by f prime of x equals 2 cosine of x cubed on the interval negative 1.9 to positive 2.2. And then hint, use your calculator. All right, so first thing I want to do is I actually want to graph this f prime, right? And I'll explain why in a little bit more detail. But let's graph f prime. All right, sorry about that. All right, so let's graph f prime. All right, so we've got y equals cosine of x squared, I believe, right? All right, so cosine, sorry, 2 cosine of x cubed, I apologize. All right, so let's go here, insert a 2 cosine of x cubed. All right, so let's change that to a cube. All right, 2 cosine of x cubed. Now, you also want to make sure that your mode is in radians. All right, and so we have that. And then we also want to set our window. So it tells you that x is between negative 1.9 and 2.2. And so you want to change your window to be an x minimum of negative 1.9 and then an x max of positive 2.2. Right? Now, that's X minimum and maximum. Now, when you graph, you're going to see this. Now, this is not bad, but sometimes you might want to adjust the Y's, right? So let's say it's like negative like 3 and positive 3, and maybe that will get you a little bit better view of the Y values, right? So you can see things. All right. So now the first question, remember, this is a graph of uh, f prime, right? And so I'm just going to grab this graph real quick. All right. All right. And so let's grab this. All right. So that we can draw on it. All right. And so remember, this is f prime. All right. So it says, how many points of inflection does this have? Well, remember, point of inflection means what? That f double prime changes signs, right? So f double prime changes signs means that the slope of this graph changes signs, right? So here you can see that the slope changes right there, right? Right? Changes from positive to negative. Then the slope changes again here from negative to positive. And then here, remember, this is a positive slope, then a negative slope, right? Then it changes again here from negative to positive. Then it changes again here from positive to negative. And then it changes again here from negative to positive, right? So all of these times are when the second derivative is changing sign. So 1, 2, 3, 4, 5, 6, right? So how many points of inflection does f have? 6. How many relative maxima does f have? Now remember, you're not counting when this graph has relative maximum. You are counting when f does, right? So what does f have a relative maximum mean? Remember, okay, if you have relative max on f, the derivative is changing from positive to negative, right? So what does that mean? This graph is changing from above the x-axis to below the x-axis, right? So remember, this graph is above, then below. So this would have a relative max, right? This graph here is changing from below to above, negative to positive, right? So this would be a relative minimum. Okay, here above to below, positive to negative, so max. Here below to above, so that would be a minimum. And then here, this would be another maximum, right? So how many relative maximums? 1, 2, 3, right? So 3 relative maxima. All right. Now, to the nearest thousandth, find the largest x value in the interval for which f has a local minimum. Well, we just talked about local minimum here and here. So now all I want to do is I want to find that x value, right? So now I need to go back to my calculator, all right? And then I need to find the x value of the relative minimum, right? Which would be right here, right? When the derivative when this derivative graph changes from negative to positive, right? So then I just want to do second trace, and I want to use the 0 function, right? And I want to bring my cursor all the way over, right? We're trying to find this relative minimum. So I put the cursor on the left, hit enter, move the cursor to the right, hit enter. And now I don't need to guess because there's only one 0 on that interval, all right? And so I get x equals 1.6765, right? We want to round to 3 decimal places, so 1.677, 1.677. So x equals approximately 1.677. All right, and then lastly, how many critical points does f have on the interval? Now, remember the interval is -1.9 to +2.2, not including, right? So we're not including those endpoints, right? So remember, critical numbers, right? Critical numbers are locations where f prime is either 0 or undefined, right? So it is never undefined, but you do see that it is 0, 1, 2, 3, 4, 5 times. So the answer is 5. All right, so that is problem number 12.